Hello everyone. In this video, we'll be solving a problem on singly reinforced beam using limit state design. So this is a design example. So let us take this design example. Design a singly reinforced concrete beam of width 250 mm subjected to an ultimate bending moment of 130 kN meter. Use M20 grade concrete and Fe 415 HYSD steel. So first let us see what is given. So they have given the width of the beam, that is B equals to 250 mm. They have given the ultimate bending moment, which is 130 kilonewton meter. We need to convert it into Newton mm, which is 130 into 10 to the power 6 Newton mm. They have given FCK, that is 20 MPa, and Fi as 415 MPa. So since this being a design example, we will be using all the formulas which we have discussed in the previous video. So first is we need to find out what is the effective depth of the beam. So that can be find out using the formula D equals to square root of mu over RU limit FCK B. And we already know what is RU limit, that is nothing but 0.36 K of 1 minus 0.42. Here instead of K we can directly substitute what is XU max over D. Then once we have found out the effective depth, we need to figure out what is the overall depth, that is given using the formulas effective depth plus cover plus half of the diameter considered. Then once we have found out the overall depth, we need to find out what is my ultimate uh, limiting moment of resistance, which is given by the same equation RU limit into FCK into BD square. We need to compare the moment with the limiting moment, and we need to distinguish what type of section it is. And in the end, we need to find out what is the area of steel required. So these are the formulas which we are going to use it in this problem. So let us go with the first step. So we need to substitute all the values in this. We already know what is moment. We need to find out what is my RU limit. RU limit, the equation is 0.36 K into 1 minus 0.K, where K is XU max over D. Since the grade of steel which is given is Fe415, if we refer to the clause 38.1 of IS code, so we will be getting 0.48. Just substitute the 0.48 in this RU limit, then we getting RU limit as 0.1379. So we got this RU limit, we know what is my ultimate bending moment, and once we substitute this FCK20 and width of the beam as 250, we'll be getting a depth of around 434.115 mm. So we know what is my overall depth formula. So here the depth, we need to increase it 5 to 10%. So whatever depth we are getting, this is my limiting depth. That means if we take a depth below this, then the beam will be converted as a over reinforced. To overcome or to avoid that, what we are doing is we are increasing the beam depth from 5 to 10%. 5% increment is for the beam having a depth of less than 500, and 10% increment is for the beam which is having a depth of more than 500. So I am increasing here the depth, effective depth 1.05 into 435. Then cover based on IS table 16 page number 47, we will be considering based on the exposure environmental, and here we are assuming 20 mm dia bars, so which is giving me around the overall depth as 496.75 mm. So I am equating it to 500 mm. So this 500 mm is multiple of 25 mm, so I am not going to increase it much, I am keeping it as it is. Now the effective depth will be nothing but 500 minus, sorry, here it is effective is small d. So effective depth is nothing but overall depth minus effective cover minus half of the diameter of the bar, which is giving me around 460 mm. So once we got, now we need to find out what is the limiting moment of resistance and compare it with the given moment. So the limiting moment of resistance formula is same. RU limit FCK BD square. So I know what is RU limit. I already have calculated here. So I'm substituting these values. FCK I already know, that is 20. B is 250, which is given, and whatever uh, uh, effective depth which we have found out here, we need to substitute it here, and whatever it will give me a limiting moment of resistance. So as you can see here, this is 145,898,200. These units are Newton mm. I need to divide it with the 10 to the power 6 to convert it into kilonewton meter. So this is my limiting moment of resistance, that is actual capacity of that beam. So now whatever moment, bending moment they have given, it is only 130 kilonewton meter, which is lot lesser than the capacity of the beam. Hence this is considered as a under reinforced section. So the remaining steps are to find out the AST. We now need to redesign the effective depth. The area of steel required is given using this formula, and I substituted the values. So here it is FCK over Fi and 4.6 into mu. Mu is whatever given moment we need to substitute in terms of Newton mm, 130 into 10 to the power 6. So this is FCK BD square. So FCK is 20, B is 250, D effective depth is 460 square into BD. So 250 into 460. So which is giving me around 243.43 mm square. So this is the required reinforcement for the moment which they have given. Now let us assume 20. Initially we have assumed 20 mm dia bars. So now let us find out what are the total number of bars required for this AST required. So the formula is, this is the formula we can use. So AST required divided by pi by 4 d square of 1 bar. So here dia is nothing but 20 mm square, which we assume. So it is giving me around 3.004. If I consider 3.004, then you can see this is more than 3. And if I provide 4 bars, then it will be drastically increase the area of steel, which also be a component for to become it as a over reinforced. To avoid that, let us take another diameter of bars. Let us consider 16 mm dia bars. Now I am repeating the same steps. Area of steel required divided by pi by 4 into 16 square, which is giving me 4.69. So it is, if I equate it to 5, then it is sufficient. Now in the step 5, I need to compare the area of steel provided with respect to area of steel required. So they have given, we got 5 bars. We are providing 5 bars of 16 mm dia bars. So this is giving me an area of AST of 1004.8 mm square, which is greater than AST required. So this will be safe. We need to perform the checks. So as per the code they have given, clause 26.5.1.1, page number 47, the minimum tensile reinforcement required is given by AST minimum equal to 0.85 BD over Fi. So 0.85, I am substituting the values 250 into 460 over 415. So which is giving me 244.25 mm square. So this is the minimum reinforcement required for the beam. So but how much are we providing here? We are providing 1004.8 mm square. Since this is this value provided AST is greater than the minimum required, so hence this is safe. Now we also need to check for the maximum tensile reinforcement. So maximum tensile reinforcement clause is given in same clause 26.5.1.1b, page number 47, saying that the maximum area of steel tensile reinforcement should be provided is 4% of overall area of the cross-sectional area of the beam. So it is 0.04 into B capital D overall depth. So I am substituting the values of B and D. As you can see, I am getting maximum reinforcement I can provide is 5000 mm square. Since whatever I have provided, since that is lesser than this, so this is also safe. So once we have found out the area of steel effective depth, I need to plot the cross-sectional detailing. So I have drawn the square rectangle beam, which is having a overall depth of 500 mm. So I need to show what is my effective depth, that is 460 mm, and I also need to show the number of bars. So these are the 5 number of the 16 mm dia bars. So this is how you need to design a design problem for a singly reinforced section. Thank you.